So hello and welcome back. So in this video I have to go back a little bit in polynomials because in polynomials I didn't start, technically I did not start at the very beginning, and if you remember in the beginning of polynomials, for example, I told you that I couldn't give you a very good definition of what a polynomial is, basically why we call a polynomial a polynomial. But then now we got to factorization and division of polynomials, and for that reason I have to go back and talk a little bit about some basics of polynomials. Start at the very beginning, and we'll have to go through the division theorem, the remainder theorem, and there is one more theorem in polynomials that is important here, and then we will continue with the rest of what we were doing. It's not going to be, it's at most going to be a couple of videos, probably 2-3 hours, and then we will get to the rest of the material that we have. So to start, basically, hopefully you are familiar with algebraic expressions. So basically what an algebraic expression is, so basically let me start this way. So basically what a polynomial is, and I should probably have started with this part, but well, I didn't, and now, but it's okay. These are the things that we haven't discussed before, so we discuss them right now, and it's not going to it's going to be all good. So basically what the polynomial is, basically, and by now we have had numerous examples, and you know what I mean when I say a polynomial. But what a polynomial is a specific kind of algebraic expressions, a special kind of algebraic expressions. Okay, and what these algebraic expressions are, basically you start with you can start with variables. For example, you know that we denote variables by different letters. For example, A, B, C, X, Y, Z, and so on and so forth. And there is also, for example, usually U, V, W, and so on and so forth in mathematics. Also the Greek letters we use for different types of things. So these are called variables. And basically these are used in algebra. Now basically a variable let me start this way. For example, let's say that you have a square over here, right? So you have a square over here, and the side length of this square is, for example, 2 units, 2 units, 2 units, and 2 units. Now that the perimeter of this square is going to be 2 plus 2 plus 2 plus 2, which is equal to 16 units. The perimeter of this square is going to be 16 units. And that's basically 4 times 2, which is equal to 16 units. 4 times 2 is equal to 8. Actually, this is actually 8 units, I'm sorry. And that's the same thing as 4 times 2, okay? So let's say that you have another square, and the side length of that square is 3 units. So then again, the perimeter of this square is going to be 3 plus 3 plus 3 plus 3, which is equal to 12 units, which is again the same thing as 4 times 3, which is equal to 12. Okay, so if I want to do a general case for, if I want to represent this situation for basically for a general square, what I can do is that I can say that, so the side length of this square, I'm going to denote it by A, and then the perimeter of this square, as we saw here, is basically 4 times the side length. So it's going to be 4 times the side length, which is equal to 4A. Okay, so now basically this 4A, basically 4A that you can see over here, you can call it an algebraic expression. Okay, now algebraic expression can have basically different forms. For example, you can have an algebraic expression in this way, or you can have an algebraic expression in basically in this way. Create a new sheet over here. Or you can have, for example, an algebraic expression in this way. For example, you can have a square over here, and the side length of the square, let's say it's A, and the area of this square is going to be basically the base times the height, which is A times A, which is equal to A squared. Okay, and so for example, the area of 4 such squares is going to be 4 times A squared, which is equal to 4A squared. Excuse me. Okay, so basically in the previous example, you saw that the area was, I don't know, the algebraic expression was in the form 4A. Well, there's one of those big insects that has come in, and it's distracting me. So there was that algebraic expression that I got, that it was 4A, then we had also A squared, then we had also 4A squared, and you can have different forms of algebraic expression in this way, referring to basically representing different kinds of situations. And by the same logic, basically for example, let's say that you have that was the perimeter of the square that was the perimeter of the square, and this was, for example, the this was the area of the square, So then, for example, if you want to represent, if you want to write an algebraic expression to represent the area plus the perimeter together, it's going to be equal to a squared plus 4a. Okay, so this is again an algebraic expression. This is again an algebraic expression, and in the same way you can have any sort of basically any exponent for your variable, and then and then some other terms added to that term, and so on and so forth. So these are called basically algebraic expressions, and you can do whatever you wanna do in mathematics. You have to almost in all cases you have to write an algebraic expression related to that situation, and then use it in some way. For example, I don't know, then using the different tools that we have in mathematics, you do some sort of operation on the expression, and then do the kind of thing that you want to do in that particular situation. Now, these basically these polynomials that we have been talking about this whole while, these polynomials are basically, as I mentioned before, they're a special kind. They are a special kind of algebraic expressions. Algebraic expressions. And what I mean by that is that, for example, you could have an algebraic expression like, for example, the square root of x plus 4x, for example, right? And if you rewrite this expression, that would be equal to x raised to the power 1/2. X raised to the power 1/2 plus 4x. Okay. Now you see that the exponent of x over here is 1, and the exponent of x over here is 1/2. And 1/2 is not a whole number. Here it's a whole number. Here it's not a whole number. So this kind of thing, this kind of algebraic expression is not a polynomial. It's not a polynomial. A polynomial is the kind of algebraic expression in which the exponents of the variable is a whole number. So an algebraic expression in which the exponents of the variable, is a whole number. And you know what whole numbers are. Basically 0, 1, 2, 3, 4, all the way up to infinity. Is a whole number is called basically a polynomial. So basically a polynomial is an algebraic expression in which the exponent of the variable is a whole number. Okay. So then basically this kind of thing, for example, then by this definition, 4a squared plus 6a plus 2 would be called a polynomial, but basically would be called a polynomial in one variable. Meaning that you have only a over here. Now we could have polynomials in for example in 2 variables, in 3 variables, for example 4xyz plus 3xy plus 2, for example xy squared z cubed, for example. This is also a polynomial, but a polynomial in 3 variables. But basically we are not talking about polynomials in more than 1 variable, at least in these few videos that we are doing on polynomials. We will talk about them in later videos. Okay, I mean not in this, not at least right now. And basically when you have a polynomial like this, so let me actually erase this. So when you have a polynomial like this, this is basically a polynomial in one variable. So you see that that you have these different parts that are basically connected together using either an addition sign or a subtraction sign. So these little islands that have been actually connected together using either addition or subtraction, these are called the terms of a polynomial. Terms of the polynomial. Okay, and then when you get into the different terms of the polynomial, for example 4a squared, as we discussed before, is a term of the polynomial. So when you have a term, this term has different parts. You have the constant part, you have a constant multiplied by the variable raised to some power x, the raised to some power, for example, I don't know, a, for example. So we are not concerned about this exponent right now, and well, you have some variable over here, for example a, b, c, d, x, or whatever sort of variable you might have, but then there is a constant over here that has been multiplied by this whole thing over here, and this constant, it's either 1, 2, 3, and so on and so forth, and this constant is basically called the coefficient. Is called the coefficient of this term of this polynomial. That's called the coefficient of this term of this polynomial. And so basically that is that. These are the little different things about polynomials that you might actually not know, and these are actually important because we have to talk about them in different situations and scenarios, and so when I say, for example, a coefficient, I must know what I'm referring to, you must know what I'm referring to, so these definitions are necessary. And then there is also something called the constant polynomial. So the constant polynomial is basically the kind of polynomial in which, first of all, there is only one term. For example, in the previous example we had, for example, 4a squared plus 6a plus 3, for example, something like that. Okay, so in this polynomial you have 1, 2, and basically you have 1, 2, and 3 terms. You have 3 terms in this polynomial, and you have 3 terms because it's not possible to actually add these 2 terms together, meaning that a squared and a, of course you cannot add them together, so they remain, they become basically 2 different terms of the polynomial. And if you were to rewrite this whole thing, you would write it as 4a squared plus 6a plus 3 into a raised to the power 0. A raised to the power 0 is equal to 1. So 1 times 3 is equal to 3. Okay. Now suppose that I take this term of this polynomial and write it as a 3, for example. So this 3 is actually called a constant polynomial. Okay. And a constant polynomial, you can write it as anything, meaning that it's actually a valid polynomial. You could write it as 3x raised to the power 0, or 3a raised to the power 0, or 3b raised to the power 0, and so on and so forth. Meaning that whatever the variable was, the exponent of the variable was 0, so of course you didn't have to write it. And there is the constant polynomial 0 is called the 0 polynomial. And there is also the kind of constant polynomial which is called the 0 polynomial. Meaning that in the same situation, suppose that you had of course I cannot write it over here, but by the same logic, when you can have, for example, 3 as a constant polynomial, then by the same logic you can have 0 as a polynomial as well, and this is called a 0 polynomial. And what that means is that the 0 polynomial was basically something like 3, and that is, if you want, you can rewrite this as 0 times, for example, x raised to the power 0. Now x raised to the power 0 is equal to 1. 1 times 0 is equal to 0. So you just write it as 0. And that's basically called the 0 polynomial. Now there is a couple more things over here to cover, but before I go any further, I need to take a few minutes rest. Okay, so far we have basically talked about almost everything that we have here about polynomials. There is one little thing about notation, and that is basically if you have a polynomial, if basically the variable in the polynomial, if the variable, for example, is for example x, you could have any sort of variable. You could have x, y, z, a, b, c, and so on and so forth. Then you can denote that you could denote that polynomial as p of x, for example, or q of x, or you can denote that as r of x, and so on and so forth. So for example, you could write, for example, p of x is equal to, for example, I don't know, 2x squared plus 5x plus 3, and that's a polynomial, in variable x, for example. So far, basically that's all about the basic things, and then there is some also terminology about the number of terms that the polynomial might have. If a polynomial has only one term, then that polynomial is called a monomial. For example, if you have a polynomial like, for example, 2x, or if you have a polynomial like, for example, 5x cubed, or if you have a polynomial like, for example, even a 2, that's basically, these are monomials because each of them has only one term. If a polynomial has only two terms, then that polynomial is basically called a binomial. Only two terms, meaning that, for example, let's say that you have, for example, x plus 1. Let's say that p of x is equal to x plus 1. Or let's say that, for example, q of x is equal to x squared minus x. These are called binomials. And there is also something called a trinomial. If your polynomial has only three terms, then that polynomial is called a trinomial. For example, let's say you have let's say that you have, for example, p of x is equal to x plus x squared plus pi, for example. Or for example, let's say that r of x is equal to u plus u squared minus 2, for example. These are called trinomials. Each of them has three terms. And there is also something about the degree of a polynomial, and that's basically the highest power of the variable in the polynomial. For example, if you have, for example, something like p of x is equal to 3x raised to the power 7 minus 4x raised to the power 6 plus x plus 9, then the degree over here is the highest power of the variable, which is 7 here, so this is a polynomial of degree 7. And also the degree of a non-zero constant polynomial, for example, let's say that you have a polynomial p of x is equal to 7. This is a non-zero constant polynomial. The degree of this polynomial is zero. Degree is zero. Because you can write p of x as 7 into x raised to the power 0, and x raised to the power 0 is equal to 1, so you would still get 0. So now, as far as the degree of a polynomial is concerned, if the degree of the polynomial, if the degree of a polynomial is 1, then that polynomial is called a linear polynomial. a linear polynomial. So for example, let's say that you have p of x is equal to 4x plus 5. So the degree here is 1, so that's basically called a linear polynomial. And something interesting that you would actually not pay attention to this most probably, and it's not actually possible to find a linear polynomial that has 3 terms. A linear polynomial can have at most 2 terms, meaning that in fact every linear polynomial will have at most 2 terms. And in general form, a linear polynomial would be of the form, the general form of a linear polynomial would be basically ax plus b, a not equal to 0, because if a was equal to 0, then this would be just b, and that would be a constant polynomial. And now if the degree of a polynomial is 2, then that polynomial is called a quadratic polynomial. The general form of these quadratic polynomials is ax squared plus bx plus c. Again, here a is not equal to 0, and as an example you can say, for example, 5 minus y squared, or 4y plus 5y squared, or you could have countless examples, of course. So basically a quadratic polynomial in one variable, something like this, or of this general form, will have at most 3 terms. At most 3 terms. You cannot have more than 3 terms in a quadratic polynomial in one variable. Okay. And then if the degree of a polynomial is 3, then that polynomial is called a cubic polynomial. A cubic polynomial. The general form of these polynomials is basically ax cubed plus bx squared plus cx plus d, and here again a is not equal to 0. And then and of course, based on this, you know that a cubic polynomial in one variable can have at most 4 terms basically. And then basically, if you want to have a general way of basically representing polynomials of degree n, so then a polynomial of degree n in one variable can be represented as basically a of n, x raised to the power n, plus a of n minus 1, x raised to the power n minus 1, plus a of n minus 2, x raised to the power n minus 2, plus all the way up to a of basically a of 1, x raised to the power 1, and plus a of 0. Okay, so a of 1, and then that would be a of 0. And in this, basically in this way of representing the polynomial, a of 0, a of 1, a of 2, and so on and so forth, all the way up to a of n are constants, and a of n is not equal to 0. And in particular, in this way of representing the polynomial, if basically a of n is if, let me write it this way, if a of 0 is equal to a of 1 is equal to a of 2 is equal to a of 3 is equal to all the way up to a of n is equal to 0, then meaning that all the constants here are equal to 0, then we will get the 0 polynomial, which is denoted by 0. And one important thing about the 0 polynomial is that the degree of the 0 polynomial, the degree of the 0 polynomial is not defined. Okay, is not defined. The degree of the 0 polynomial is not defined. Okay, so we basically talked about polynomials in more than one variable, but we are not going to talk about these polynomials right now, so we'll do that later. Now, there is one important thing here about the zeros or roots of a polynomial, and of course I have talked about this in the previous videos as well. But there is one thing that we need to be able to distinguish between. Basically, there are two things actually that we need to be able to distinguish between, and that is the difference between zeros and roots of a polynomial. Zeros and roots of a polynomial. Basically, when you use the word root, the word root basically refers to is usually used in case of an equation. The word root is usually used in case of an equation. Now that equation could come actually from anywhere. It could come from a polynomial or any other situation for that matter. But when you say when you use the word zero, that word, the zero is actually a little bit, used a little bit differently, and we will see, basically, I will see what basically what I mean by that in a simple example. So consider, for example, the polynomial, for example, p of x is equal to x minus 1. Now if you calculate p of 0 in this polynomial, is going to be equal to, p of 1 if you calculate p of 1 in this polynomial, it's going to be 1 minus 1, which is equal to 0. So that means that when x is equal to 1, the output of the polynomial is 0. That means that basically what that means is that 1 is the zero of p of x. That's basically how you use what the word 0 actually means. Okay, so in general, basically there's a zero of a polynomial p of x is a number c. So basically we say that in general a zero of a polynomial p of x, for example, is some number c, such that p of c is equal to 0, meaning that if you use that number as the input of the polynomial, the output actually goes to 0 or becomes 0. Now over here, when we wanted to find, if we actually were to find this number 1, what we would have to do is that you have p of x is equal to x minus 1. So here and the condition for this number 1 to be a 0 of this polynomial is that if I use this number as an input of the polynomial, the output of the polynomial has to be equal to 0. So if I simply set the output of the polynomial to 0, then I'll be able to find that input at which the output is equal to 0. I'll do the same thing. So I set p of x is equal to 0. That means that x minus 1 is equal to 0. That means that x is equal to 1. So now as you can see, in order to find the 0 of a polynomial, which is basically this number over here, I had to equate the polynomial to 0, and as a result of that I got this polynomial equation. Okay, I got this polynomial equation. So then you can say that one is the 0 of p of x, of that polynomial we were talking about, or the root of the polynomial equation, or the root of the polynomial equation x minus 1 is equal to 0. So this is actually a polynomial equation, and the root of that polynomial equation, if you solve it, you'll get the root 1. Okay. And basically when it comes to finding the zeros of a polynomial, in the case of constant polynomials, there is no zero. Meaning that, for example, if you have some polynomial like, for example, p of x is equal to 5, this has no zero. And the reason for that is that if you say that p of x is equal to 5, then you can write this as p of x is equal to 5 into x raised to the power 0. And what that means, and then in order to find that x, you would have to set p of x is equal to 0. And so 5 times x raised to the power 0 is equal to 0. And this is basically impossible, because there is no x that can fulfill this condition, meaning that you are multiplying some number by 5 and you're multiplying some number here by 5, and the result is 0, meaning that number has to be equal to 0. So that means that x raised to the power 0 is equal to 0. But any number, if you raise it to the 0th power, you're going to get a 1. Any number raised to the power 0 is equal to 1. So this is actually actually not defined in mathematics. There is no way to solve this equation. So basically, in the case of a constant polynomial, there is no 0 to find actually. And that's basically that. So basically then you can basically briefly say that a non-zero constant polynomial has no 0. Okay? And there is some convention about the 0 polynomial. So these are all basically definitions and conventions, and you need to be familiar with them. So about the 0 polynomial, by convention, every real number is the 0 of the polynomial. So every real number, by convention, convention is the 0 of the 0 polynomial. So the constant polynomial has no 0, and the 0 polynomial, the 0 of the 0 polynomial is every real number. And of course you know that how to find the 0 of basically linear polynomials and quadratic polynomials and cubic polynomials. And I suppose in the previous video or the video before that, or somewhere around that point, we came all the way up to the cubic polynomial, and then we needed to basically factorize a 3rd degree polynomial, and then for the same reason I had to come back here and basically do this whole thing. Now in the next video I am going to talk a little bit about the remainder theorem, and then we have also something else called the factor theorem also, and there are some identities that we can also talk about as well. I don't know if, of course, you're going to need all of these identities in algebra, and in polynomials to be able to talk to work with them and factorize them and things like that. So basically the next things that we will discuss here is the remainder theorem, and then there is also the factor theorem, and there are also some identities and these are actually useful things when it comes to working with algebraic expressions and polynomials. So we will talk about all of them in the next videos. I'll see you in the next videos. Thank you.